So now let's balance this using the half reaction. However, we were given a new condition. Okay, we were told this is an acidic condition. So in other words, that means that in order for this reaction to be a redox reaction, it has to be in an acidic solution. To be in an acidic solution. And you wouldn't have known that yet, okay, beginning chemistry student. But now we're telling you, okay, we can balance this reaction, but it has to be done in acidic conditions. How are we going to do it? Here's how, okay? We first split it up into two halves, and I can base that from the atoms. So like I see, here's an iron half, great, and here's a manganese half. So let's split those up. So I'm going to say over here, iron 2 plus makes iron 3 plus, and maybe hopefully what you can see right away, we need 1 electron to balance that, right? 3 minus 1 gives me 2, okay? And that's it. That one's done. Easy. So what about this manganese half? Okay, so I'm going to write this way over here. I'm going to try to give myself plenty of space. I'm going to drop the phases for now just to make this easier, but I'm going to bring them back in at the end. Okay? And so now, let's see, did I give myself a good amount of space? I probably did, and I'm going to shift this whole thing over just a little bit for more space. Okay. MnO4 minus permanganate, right? Okay. So the first thing I recognize with this, there's 4 oxygens on this left side, and there's no oxygens over on this side. So how am I going to deal with that? Well, it's aqueous. Look, aqueous. That means we have water. Water is around. It might not be written in this chemical reaction, but it means we have it and we can use it. And I'm going to use it, and I'm going to say plus 4 H2O. And the reason why I said 4 of them is because I want to balance those 4 oxygen atoms. And I can balance those 4 oxygen atoms by adding 4 water molecules. Well, now we're going to play this back and forth game, because now you might say, well, we've added 8 hydrogens that we didn't have over on this side. And that's true. But this problem told us this has to be balanced in an acidic solution. And so what that means is these 8, 4 times 2 is 8, hydrogens, I can balance by saying 8H plus. Not just 8H or 4H2, I need specifically 8H plus because that makes it acidic. Okay? And now, when I inspect this, I've got 1 manganese, 4 oxygens, 8 hydrogens, and 8 hydrogens. However, what about my charges? Okay, well, on this side, 8 times plus 1 is plus 8, minus 1 is plus 7. So water is 0, 4 times 0 is 0. And manganese is plus 2 plus, right? So its oxidation state is plus 2. So I can balance these numbers now by taking away 5. And the way I take away 5 is by actually saying plus 5 electrons. Okay? So now plus negative 5, right? And that's going to balance it out. Beautiful. So now that I've balanced each half, I can bring them back together. Okay. And let's see, I'll write the iron on top. You know what I realized I also forgot to say on this last problem, but now I'll add it on this problem, okay? This half, right, that's going on, iron 2 becoming iron 3 plus an electron. Look, it's the iron 2 is losing an electron. So, yep, you guessed it. This is the oxidation half. So that means, look, this permanganate is gaining an electron. So that means this was the reduction half, okay? Right, I said that in the beginning. All reductions have to have an oxidation. All oxidations have to have a reduction. So when we split these up into the halves, we're really splitting it up based on its two respective half reactions. Okay, so now we've written this iron reaction down. Let's write this manganese reaction down, okay? Plus 8H plus 5 electrons. And that makes Mn2 plus 4 H2O. And hopefully what you can see, I hope you can see this, the electrons ended up on opposite sides, so that's how we know we're good. If your electrons end up both on the same side, you can't cancel them, so you did something wrong. But also, I have 5 on this side and 1 on this side, so the easiest way to balance that is to multiply this entire reaction by 5. Okay, and so I'm just going to write the result down directly. When I do that, I get 5 iron 2 plus aqueous plus 1 permanganate plus 8 hydrogens. We know the electrons and the electrons are going to cancel, that it's, it's 5 and 5, okay? And now I have 5 iron 3, let's write that again, 5 iron 3 plus aqueous plus, let's see where we're at, 1 manganese cation plus 4 H2Os, and water is always a liquid unless it's a solid or a gas. And so now everything should be completely balanced in this thing. Right? We've got 5 irons and 5 irons. We've got 1 manganese and 1 manganese. I've got 4 oxygens and 4 oxygens and 8 hydrogens and 8 hydrogens. Well, what about the charges? Okay. Well, look, 5 times 3 is 15 plus 2 is 17 plus on that side. Do we have 17 plus on the other side? I hope so. We've got 5 times 2 is 10. Plus 8 is 18 minus 1. Hallelujah. 17 and 17. So it's balanced. Shoo-wee. Okay. This was a harder one. All right? For sure, this was a harder one. Be able to do it. All right? Be able to do it. Okay? Lots of practice in the book, and there's some problems like this on your homework too. Okay? So, what's happening with this thing here?